In this video, we're going to begin looking at a technique for solving a type of word problem in algebra that's classified as a mixture problem. A mixture problem is any time you are mixing two different quantities together, two different types of things together in order to get a whole new item. Okay, so generally these can be used as, you're going to a show that has both student and adult tickets, or child and adult tickets, and you want to know how many of each are you getting. So that's one type of problem. Another type of problem is you're mixing in chemistry two different types of solutions together. It's huge. Another thing might be you're going to a grocery store and you want to get some walnuts and some almonds, and based off of what price you want to pay, you want to know how much of each are you getting. So all these are types of mixture problems. In general, what you are doing is we're going to use a chart method to solve this. The way the chart is set up is usually you have an original solution or original type of object. You have the original. To that original type of whatever, you're going to be adding something in order to get a final solution. Okay, sort of the end result. Okay, almost always you are given some sort of rate. And I can tell something's a rate by the fact that there's a percentage after it, or there is the word per. It's so much per ticket or per pound. Okay. You're going to have the original amount or the amount of something. This could be the amount of tickets, the amount of solution you have. Okay, you begin with some sort of amount. Okay. And then you end up with some sort of final quantity. Okay, this final quantity is almost always given by the amount of something times whatever the rate is. So it could be, you have 5 pounds of nuts at $5 per pound. Okay, something like that. So there's some sort of total, and that goes in this last column. So as we go through reading these word problems, this will pretty much be always the chart that you're going to be filling out. The difficulty with these becomes where do you place stuff? And how do you read the problem so as to be able to fill this out? Eventually, you will need to fill in all the labels by yourself. As we begin, I'm going to start off giving you most of these labels to begin with for each of the problems to help you in filling these out. Look at our first problem. Okay, this is a solution problem, a mixture problem, where I have 50 ounces of a 25% saline solution. So the 50 ounces and the 25% solution will go together. So that's what I have. That's what the original amount is. The fact that I have 50 ounces of that original solution, and it's a rate of 25%. So I have a choice. I can either keep it as 25 or I can write it as 0.25. Okay. The biggest thing is that whatever I decide to do, if I start off with using 25, I have to use 10 and 15 for the other two quantities. If I put 0.25, I need to keep it as 0.25 and 0.10, 0.15. Okay. The next thing it says is how many ounces of a 10% solution must you add? So that's what I'm going to add. I'm adding an unknown amount of a 10% solution. Must you add to make a new solution that is 15% saline? So I want the mixture to end up being 15%. Okay. Do I know how much is in the mixture? No. Okay, so I have two options here. For this amount of the final mixture, for this space, I have two different things I can do. Okay, one of the quantities is saying that if I have 50 ounces of solution and I add, say, 20 ounces, how many ounces do I have in the end? Well, 50 plus 20 that I'm adding should end up being 70. So one of the ways of approaching these problems is then to say, oh, this would be 50 plus x. And in general, that will always happen. This box plus this box should equal this third box. Okay. I could also say the mixture is y, okay, that an unknown amount, and set up an equation that 50 plus x equals y. Okay. So then following what we talked about in the last slide, that the amount times the rate would equal the total, I would do 50 times 25, in which case, which is going to be 1,250. The 10x, I'm going to just leave as 10x. And the 15 times the 50 plus x, I'm going to leave as 15 times 50 plus x. Okay. So basically what ends up happening then here is the same thing that happened in the first column. The original total plus the 10x will equal what's in the last box. So in other words, 1,250 plus 10x will equal that 15 times 50 plus x. In this case, the 15 times 50 will end up equaling 750 plus 15x. Okay, so if I want to simplify, what I can do is subtract the 10x from both sides and get 1,250 is equal to 750 plus 5x, because the 10x's cancel. Subtract the 750. I get 500. It's going to equal 5x. Divide by 5, divide by 5. In this case, the x is going to be 100. So I must have to add 100 ounces of the 10% solution. Okay. As you get your answer, you always want to make sure you plug it back in, okay, and that you're aware of what is the question that's being asked to make sure you answer it correctly. Just as a little side note, let's pretend this was y, okay. This would end up being 15y, so therefore then my two equations would be set up, first of all, from this first box, that 50 plus x is equal to y, and then from this last box, I would end up with 1,250 plus 10x is going to equal 15y. Okay, and then you can either use substitution or you can use elimination in order to be able to solve that. Or if you wanted, you could even solve graphically. Okay, which is always a good sort of thing to keep in mind. Let's take a look at another type of mixture problem, this time with tickets instead. The setup's going to be a little bit different here. Okay, but still follows the same general idea with the chart. Instead of having an original and something you're adding, we're going to make one of those rows an adult, one of those rows a children. So here it tells that a school play costs $5 for adults, $2 for children. So a ticket is $5 per adult, $2 per children. And you'll notice I'm consistent that I'm writing in terms of dollars. It then says, for one night, there were 285 tickets were sold. That is the total that was sold. So that's the total number of tickets that were sold. And $1,065 was collected. That's the total amount of money that was collected. It's not an amount per ticket. In this case, this is a scenario where we will box off this bottom box because there's no way of comparing those two rates together. Okay, there's no average amount per ticket. Okay, so the total amount that was collected goes in that bottom right hand box. Okay, how many of each type of ticket were sold? At this point, you might be looking and saying, I don't have enough information, but actually, yes, you do. Okay, using what we've learned with systems of equations, I don't know how many adult tickets were sold, so that's going to be A. I don't know how many children tickets were sold. I'm going to call that C for children, okay? You get your choice of whichever variables that you want to use. So in a case like this, I usually pick a letter that's going to remind me about what it stands for. The total for the adult tickets is going to be 5 times the number of adults, okay? So if there's 20 adults, I make $100 off of adult tickets. Okay, similarly, the total for children's tickets will be 2C. Okay, I'm going to set up my two equations using the same process I did for the other mixture problems, where in this first column, I can say that A plus C is going to equal 285. And then for my second equation, because I've got two variables, so I need two equations, I'm going to use this 5A plus 2C is equal to 165 or 1065. Okay, so when you're setting up the equations, your first equation and what you will always use will be from this last column, and this is if you need the second equation, okay, and you sometimes use will be from this first column. So therefore, what I could do is if I multiply the first column by -2, or the first equation here, I get -2A minus 2C is going to equal 285 times -2, which is going to equal -570. So I simplify the C's cost out, I'm left with 3A is going to equal 1065 minus 570, which is going to be 495. Then I divide by 3, and I get the fact that there were 165 tickets sold for adults. So you need to make sure you go back and reread the question. It's asked how many of each type of ticket were sold. So in this case, I know that for the adults, there were 165 adult tickets. So I need to make sure I state that explicitly. And then I need that for that to add up to 285, which tells me there were 120 children tickets sold. Okay. So in this case, I've got my answer. Okay. So it looks like a lot of work, and it is. Okay. The value of using the table is it helps you to organize where all the numbers go and where all the information goes and what stands for what, and basically gives you the two equations, which is why I find the table handy. And I'd encourage you to at least begin by using that. Eventually, you might develop your own method, or you might also decide that you can put it straight from the word problem into the equations. At this point, though, my fear is that it'll become just throwing in numbers wherever they seem to happen to fit. So I'd encourage you, we're going to begin by using the tables. We're going to practice this for a few days, go into another couple type of word problems that are more just, reading the equations, a couple different types of word problems, and then we'll begin some work with the motion word problems as well.